Okay, so question number 13, page 381, is asking us to locate the image using ray diagrams. So the object is 30 centimeters away from a convex lens that has a focal length of 10 centimeters. So it's back here. So the last day we learned our rays, and one was a ray going in parallel to the principal axis will get refracted so that it comes out through F on the other side of the lens. An ray that goes in, passes through the optical center, passes straight through, and comes out on the other side. Okay? If I switch colors, a ray going in parallel to the principal axis. Principal axis isn't straight, comes out through F on the other side of the mirror, and a ray that goes in through the optical center comes out, passes straight through. And so our image will be here, where the black cross is the head, where the purple cross is the feet. Okay? Now, we could have also found it calculation-wise. They didn't ask us to. But you could have used 1 over F is equal to 1 over DO plus 1 over DI. So 1 over DI would equal 1 over F minus 1 over DO. So 1 over 10 minus 1 over 30. So 3 over 30 minus 1 over 30 is 2 over 30. So F will equal 15 centimeters. It's positive, so it's on the other side. And look at that. It should be about halfway between F and 2F on the other side, and it is. All right, number 14. An object that is 2.25 millimeters high. So HO, 2.25 millimeters. DO is 8.5 centimeters. To the left of a convex lens that has a focal length of 5.5 centimeters. Find the location and height of the image. So 1 over F is equal to 1 over DO plus 1 over DI. Why do I keep doing DOs? 1 over DI is equal to 1 over F minus 1 over DO. So 1 over DI is equal to 1 over 5.5 minus 1 over 8.5. Common denominator, I think the lowest is maybe 187. 187. 5.5 goes in. $34 times. And 8.5 goes in 22 times. So 1 over DI is equal to 12 over 187. So DI is equal to 187 over 12. Which of course we do not leave this way, because it would mean absolutely nothing. So what is that? 15.58. 3 with the 3 repeating centimeters. So that's our DI. So then our height, HI over HO. I-ho, di-do, with a negative there. HI is equal to, take your HO up, fill in your values, so negative 15.583 with the 3 repeating. HO was 2.25 millimeters. And DO was 8.5? Yeah, 8.5 centimeters. So it's going to end up being a negative, and that's just going to mean that it's erect. Or excuse me, that's just going to mean that it's inverted. It should never be typing numbers in the calculator and trying to talk at the same time. So you get 4.125 millimeters, and when it comes to height, the negative means inverted. All right, number 15. Says an object is placed to the left of a 25 millimeter focal length, so f is 25 millimeters, so that the image is the same size as the object. That HO is equal to HI, and if that's true, then DO must be equal to DI, right? Because hi-ho, da-do. So if these two are equal, these two have to be equal. What are the image and object's locations? So 1 over f is equal to 1 over do plus 1 over di, which is the same as saying 1 over do plus 1 over do. So 1 over f is equal to 2 over do, so do is equal to 2 times f. So do is equal to 2 times 25, or 50 millimeters, and that's also di. All right, and the last one says a lens is needed to create an inverted image that is twice as large as the object. So for 16, we want the image to be twice as large as the object. So HI is equal to 2HO, or in other words, the magnification is equal to 2. When the object is 7 centimeters from the lens, so DO is equal to 7 centimeters. What focal length is needed? Okay, so magnification is equal to DI over DO. So DI should be equal to 2 times the 7 centimeters. DI should be equal to 14 centimeters. 1 over F is equal to 1 over DO plus 1 over DI. 1 over F is equal to 1 over 7 plus 1 over 14. 1 over F is equal to 2 over 14 plus 1 over 14 is equal to 3 over 14. So F is equal to 14 over 3, or what do you get? 14 over 3, 4.6 repeating centimeters. Now, whoops. I didn't put the negative in because I knew it wasn't virtual, right? Because it said object is 7 centimeters. A lens is needed to create an inverted image. Inverted, so I guess technically we could say it was inverted, then this would be a negative here, which would make this a negative here, which would make this a negative here, and it would cancel that negative out, and it would be positive. Sorry, I just ignored the negative because I knew it was a real image. But how did I know? Because it said inverted. Okay? All right, there are your homework questions, or suggested practice problems. And so now it's time to get colored pencils. Okay? Next video, cases.